no land to build on, no scaffolds to stand on. An American EPC was tasked with building solar directly over a flowing canal. The designs failed, the ground was water, so they reinvented everything. This is solar like you've never seen it. Watch it all unfold on this episode of Sailing the Storm, only on ENF TradeTV. Good day, ladies and gentlemen, and welcome to Sailing the Storm here on ENF TradeTV. Today, we have another exciting episode lined up as we are joined by BEI Construction all the way from California, USA. So, hi John, and please introduce yourself and your position in the company.
Sure, yeah, my name is John Orbell. I'm a project manager here with BEI Construction. Been working here for about 2 years and in the electrical industry for about 6 years.
So John, let's talk about the most challenging industrial installation you've ever faced with your entire time in BEI Construction. Can you tell us the story?
Sure, yeah, we're working on a project right now in the Central Valley of California, so farm country for those who aren't familiar with the area. And the project we're working on, it's called Project Nexus. It's a pilot project that's being put on through the Turlock Irrigation District, which is the water and power utility in the area with funding from the state of California.
Thanks, John. Could you explain to us the technical requirements of Project Nexus in detail?
This is a really unique project. It's sort of a first of its kind here in California. And the idea is that, the water and power utility that I mentioned earlier, they operate, transmission and distribution lines for electrical power for the area, but they also operate a large system of irrigation canals that provide water for a lot of the farmland there. And so in developing this project, they were thinking a lot about how the space over those canals could be utilized for renewable energy. I think it's a really big idea because the typical land areas that are used for that kind of thing being, rooftops and paved parking lots, open land used for ground mount systems. The idea of putting solar on top of canals, I think, is really important because it opens up a whole new category of land for use in producing renewable energy. So, now that we've got canals as a potential avenue for installing solar, the big technical question becomes how you make that work structurally, like how you have a structure on top of an open body of water that's capable of supporting, the weight of the solar system. Solar panels that were used were bifacial. So they're Jinko solar panels, roughly 590 watts, I believe, but they're bifacial, meaning they can get production on both sides of the panel. And that was chosen because in addition to obviously sunlight, the typical generation we see from a solar module, we also have reflection coming up from the water. So there's additional generation there. The batteries, the modules, and the inverters are chosen by the owner.
Well, I'm getting curious, John. Given the complexity of designing a solar panel support structure over a flowing water, what innovative engineering solutions did you guys take to make sure that the structure is durable and at the same time stable?
Yeah, great question. So the project was in development for almost 2 years before construction began, and so the design went through multiple iterations, but from a very high level, it essentially started as a steel superstructure, and then cassettes of solar arrays were mounted to tensioned steel cables that were over the water. That was its first iteration, and then for a variety of reasons that sort of concept was scrapped. And then where the owner landed was essentially to build a carport style canopy structure, which here in California and in the US, that's typically built using cast and drilled hole concrete foundations that are drilled into the ground, and then steel beams erected, vertical steel beams, and then a horizontal member to connect those vertical beams with purlins that run the length of the array. that then the solar cassettes are mounted to. So without getting too technical, the basic concept as it was built and constructed was to erect a canopy structure that sits directly over the canal.
I understand that. Well, I would also love to know, how does your team address the challenges of maintaining both the solar panels and the canal infrastructure, especially in terms of accessibility and long-term maintenance?
So when we're building these systems, obviously we're building a structure over an active waterway. And on a typical canopy installation, we're able to utilize scissor lifts or boom lifts to get personnel directly underneath the work area, and same thing for maintenance. And obviously that is more challenging in a situation like this where we don't have direct access from underneath the array. So in this situation, some specialized articulating boom lifts were needed that have jig attachments on the end of them. And essentially what that allows us to do is park on either side of the array. There's an access road on either side of the canal that the array is covering, and park a piece of equipment there. And then just to be clear, the array structure is sloped, so we can park by utilizing this specialized equipment, we can park on the roadway next to it, get personnel under the low end of the array, and then utilize the jig to bring them up so they still have access directly under the array. So same thing for maintenance. If testing on strings was needed, or if there's any sort of diagnosing or troubleshooting that needed to happen on the wiring to the panels, similar equipment would be used to do that.
How do you address the increased risk of corrosion and structural wear in solar panel installations over water? How do you ensure the long-term durability and cost-effective maintenance of that?
Yeah, so I think there's a lot of best practices we utilize in the industry, regarding galvanizing of exposed metal parts that are extra important on a job like this, where you're installing something over water, but also utilizing, special fasteners, stainless steel hardware that is more corrosion resistant than the typical hardware we'd see in a normal carport type installation that's not near a coast or over a body of water. So those take extra importance on a job like this.
Okay, now let's go to environmental and logistical aspects. What were the most significant obstacles or roadblocks you encountered in this project?
One of the main concerns is frankly just preventing trash, debris, drop material, tools into the waterway that we're working over, which we do by tethering tools to workers' belts and tool belts, attaching nets below the man baskets that they're working in. So that's a concern. I think this is sort of straddling the line between environmental and logistical, but one of the key things we found in designing this job and doing some value engineering with the utility company was it makes the most sense to keep these systems close to the point of interconnection. We're building overhead structures directly underneath an active overhead transmission line. So a lot of safety concerns there. They could be 100 feet away from the actual transmission line, but there's still a risk of shock there. So in this case, that required a lot of coordination with the utility we're working for to basically de-energize this large overhead transmission line for a very defined period of time to allow our work to continue safely.
Okay. How about in terms of extreme weather risk? How are solar installations over canals designed to withstand extreme weather conditions like high winds, floodings, and seismic activity, particularly in regions like California?
Yeah, so luckily where we are in California especially, the weather never gets too extreme. So there's less of a concern there, and seismically, seismic considerations are built into California's building codes. So the main extreme weather condition that we deal with in California, and especially in the Central Valley, would be extreme heat. And I think a lot of your viewers are probably aware that when solar panels get hotter, they're less efficient. So another benefit of this type of installation where we're putting the solar over a body of water is that body of water has a cooling effect on the panels above them or above it. And so by placing it there, the same solar system, if placed over a parking lot down the street from this project, would be less efficient than ours is.
You see, John, we all know that despite thorough planning, some challenges only reveal themselves mid-project. So were there any complications or scenarios that caught you off guard? And how did you adjust your approach to overcome them?
Yeah. So I think the couple big challenges we've dealt with here. One, this project is built by having cassettes of multiple solar modules that are built on the ground and then lifted using a crane or a piece of equipment and placed on top of the steel structure. And so the most efficient way to sort of electrically build this system, if that's what's happening, is to have these modules which are plugged in series to connect them all while they're on the ground before everything's on top of the water. In this case, that didn't happen. And so again, I go back to the specialized equipment we were talking about earlier that needed to be utilized so that our personnel could gain access underneath to do that work. So that's something that sort of came up partway through construction that would be a big learning experience for us next time. And on future phases of this project, that's going to be incorporated into the work plan.
And just to make light of all the technical conversation we have in this episode, well, John, what's that one word your team said the most during the installation project, other than deadline or budget, and why?
Yeah, we try not to say deadline or budget too much. I think the word for us is partnership. So, with any construction job, construction jobs go better when there's an effective partnership between contractor, owner, subcontractors. And this project has been no different. I think this project in particular has required a strong partnership because it's a first of its kind, it's unique, it's not a cookie cutter type of installation that everybody's done 1,000 times before, and everybody knows how it's supposed to go, how it's supposed to be built, and what their roles are. And so, just having open, honest communication with all parties about things that could have been done better, things we've learned, things that went really well, everything we're going to take with us into the next phase of the project. It's all facilitated and made possible through the partnership we have with everybody involved.
And that's actually all my questions for you, John, in this episode. And thank you so much for your time.
Yeah, thank you for having me. It was really fun.
And that's a wrap for another episode of Saving the Storm. Don't forget to like, share, and subscribe. Once again, I'm your host, Charmaine, and thank you for watching ENF TradeTV, your trusted source for all things solar.